Hi, good evening. How many of you know the secret behind treating parallel rays to be coming from infinity when you are dealing with mirrors or lens? In many cases, we refer to parallel rays. They are connected to or they are assumed to be coming from infinity. How uh, that concept can be internalized. Let us deep dive into this concept, taking some real life examples into consideration. Quickly, we can get into this because this is a very fundamental understanding, fundamental concept, which we learn from class 8th, 9th, 10th, even in plus 2 physics. Whenever we encounter with optics, geometrical optics or ray optics, we regularly come across this particular concept of rays coming from infinity or parallel rays are coming assumed to be coming from an object which is at infinity. Now let me bust some myth related to the term infinity. See, infinity, the term infinity we have been using in math as a number which is endless, or infinity means something beyond our imagination or beyond the universe, like that. But in physics, we use the term infinity with specific meaning. For example, uh, whenever we define the term electric potential or gravitational potential at a particular point, what is the electric potential at a point or gravitational potential at a point? Gravitational potential at a point is the work done in bringing unit mass, that is 1 kilogram of mass, from infinity to that particular point. In that way, the potential at a point is defined. Rather, gravitational potential at a point is defined. In a similar way, electrostatic potential at a point is defined as the work done in bringing a unit positive charge from infinity to that particular point. So, we are having the notion of infinity from math, that infinity is beyond our universe or beyond our imagination or some endless number. So that is the concept we are having regarding the term infinity. So, but in physics, we are using infinity with a different kind of notion. What it is? It is simply, see, the gravitational potential at a point is defined as the work done in taking unit mass from infinity to that particular point. Where is the infinity? Let us assume, let me share my screen first. And before going into the particular discussion of our topic, let me discuss about this one. See, imagine this to be the earth, this to be the earth. Okay, this to be the earth. Now, there will be a gravitational, or there will be a boundary to the earth where gravity is vanishing. Suppose this is the boundary, that which means if you place an object here, it will not be attracted by the earth because it is outside the gravitational field of earth. Same is applicable for a positive charge also, a positive or negative charge. For example, let this be a negative charge, minus q. There will be a region or three-dimensional space around the charge where its influence can be experienced. Let the boundary is like this, at this region, towards this region. Okay, which means you will not experience any effect due to this charge beyond this line, or if you place some charge here beyond the electric field exerted by the charge, by the specific charge, it will not have any influence on this particular charge. That is the meaning of infinity in physics, in the case of gravitational field or electrostatic field. Now let us come back to our situation, which is optics, or in many experiments related to light, we consider parallel rays are coming from infinite objects. See, this is a mirror. This one, you are considering a mirror, a concave mirror. This is a convex lens. And see, in this case, these are, you will be familiar with this. This is a plano convex lens and this is a plano concave lens. So in both the cases, the rays are coming, incoming rays are parallel rays, which are assumed to be coming from an object at infinity. Okay. Now, in the case of a mirror also, this is true. See, these are two mirrors. The first one is the mirror on the top. It is, one second, let me increase the width of the pointer a bit so that you will be having better visual experience. One second. For the marker also, let me increase the size of the pen. Okay, great. Yes, see this. Now also it is appearing to be smaller. Okay, let it be so. See here, this is a concave mirror, whereas this is a convex mirror based on the reflecting surface. If the reflecting surface is concave, it is known as concave mirror. If the reflecting surface is convex, it is, or convex means bulging up. Concave means bulging down. Okay. So in these two cases, the rays are, incoming rays are parallel rays. Coming rays are parallel. But after reflection, the reflected rays are not parallel. Okay. So the situation, how we are assuming or imagining these rays are coming from infinity. So for that, I wanted to give you a few examples which are meaningful. You just imagine, let me move to the next sheet. Yeah. You consider observing this elephant. You are observing this particular elephant. You are here. Okay. 1 second. Yes. You are observing the elephant standing from here. Okay. Now you see what is the angle subtended by the elephant at your eye. See, this will be your line of sight. Line of sight means the line of vision which is parallel to the earth when you look forward. Okay, so this is your line of sight. Now, let me give the line of sight a different color. Yeah. Now, this is the line of sight. So, in order to have a total view of the elephant, you need to look the elephant at this angle from the line of sight. Similarly, you need to look down from your line of sight till this angle. So what does it mean? See, the elephant subtends an angle, this much angle at your eye when you are observing the elephant from a distance like this. Now, I'm taking you far away from here. Okay, 1 second. Let the elephant be here itself. Okay. Second. Okay, sorry. Yes. Creating some kind of, okay. No, it is not work. Okay, yeah, let me draw it further. See, I am taking the same person, observing the elephant from a distant place. Okay, now in this particular case, what about the angle subtended by the elephant at his eye? Is this much only. Actually, earlier the angle was this much, but Now the angle is this much reduced. Now, if I am taking the person even to a distant place, see, I am taking the person or the same person, he is observing the elephant from here. Okay. Now, what about the angle subtended by the elephant on his eye? See, again, the angle got decreased further. See, this much of angle. Here, it was a greater angle. Here, it was a very large angle. So, as you move away from the object, the angle subtended by the object at your eye keep on decreasing. Now you think about a situation, you are observing the same elephant, which is standing on a distant hill, which is some 2 kilometers away from you. You are able to see the elephant, but to see the whole elephant, you need to look at a single point, because at a distant object, the elephant, the huge animal elephant, which appears to be a point object for you, and all the rays coming from that particular elephant, it subtends zero angle at your eye. So that we can imagine that the object, which is the elephant, standing at a distance of 2 kilometers away from you, is making an angle nearly equal to 0 degree at your eye. See, if you consider two rays which are subtending angle 0 degree, those are parallel rays. Okay, so this is the logic. Now again, I can share the same image with another example I have given on that page itself. You see the giraffe? If the same person is observing this particular giraffe from a nearby point, see, if the person is standing here and observing this particular giraffe, see the angle subtended. It is so large, very large. But if this person, the same person, is observing this particular giraffe from a distant place, see, I'm extending this particular image. Yeah, line. I shall extend this. And the person, he is observing the same giraffe from a distant place. Now you think about the angle subtended. See this? The angle subtended again get further decreases. Now, as he moved back or away from the giraffe, the angle subtended by the giraffe keep on decreasing. It continuously decreases. As a result, what happens? Simply, all the rays coming from the whole giraffe will appear to be parallel or subtending an angle 0 degree at the eye of the observer if the observer is at a very large distance from the object. This is the simple logic we are considering parallel rays coming from infinity. Now you think about this particular insect. I have taken one insect and a butterfly. Now you think about the insect when compared to a human. See, let me shift this here. Now the person here, see, the eye of a person, human eye, will be like this. Okay. Now you think about the angle subtended by the insect at the eye of this person. See here. It's very small angle. Now, if the insect is at a very large distance or somewhat larger distance, now these two rays can be considered to be parallel rays. Okay. Same is the case of butterfly also. I have given these two examples. Now, if we are watching these smaller objects through a lens, what is happening? The lens magnifies the image of the object, or it increases the angle subtended by the object at our eye, so that we are having a visual experience of the object is placed very close to our eye. See, you think about this particular pen. I can demonstrate this also. See, here the pen is here. Now this is my line of sight. I am looking straight. Okay. Now in order to observe the pen completely, I need to shift my line of sight onto the top, then to bottom. So this much is the angle subtended by subtended by the pen on my eye. Now, if I move the pen away from my eye, then the same pen subtends smaller angle at my eye. That is the situation. Okay. Now, I hope that this concept you got clarity about, and why I am discussing about this particular topic. This is a common misconception our students are having, even starting from class 8, class 9, class 10. Even a plus 2 completing student is having the same doubt or confusion related to this fundamental concept. Okay. So I wanted each one of you having clarity on this, and to keep yourself away from these kind of conceptual or what I would say, conceptual misconceptions. Let me put it in that way, misconceptions. Okay. So be clear on each and every small concepts related to physics, which will help you enjoy physics at higher levels. Okay. According to some recent studies, many of the premier institutions in India, like IITs, NITs, JIPMER, AIMS, ICERS, they had conducted some studies to check the proficiency of their students in a subject like physics, which is very much, which is having very, very high applications in the area of mathematics, in the area of engineering, and in several areas. Physics is having applications. So these institutions conducted studies on the first year students who are getting inside after cracking top level entrance exams like JEE Main, Advanced, ICER aptitude test, NEET like exams. So unfortunately, all the institutions, including IITs, found that these students are not having conceptual understanding and deep knowledge about fundamental concepts related to physics, and they suggest to develop new learning strategies to bridge these particular gaps. And unfortunately, our education system is having several gaps and cracks when it is related to the learning of a beautiful subject like physics. So if you want to know more about these kind of gaps and cracks, I invite you to join my free webinar, which is called Physics Made Easy. It's a 2-hour live webinar. I conduct the webinar live only, and I will share various studies, statistics, and various researchers. And based on that, I will be explaining how you will be able to master a beautiful subject like physics, which is considered to be one of the toughest subject for almost all the students. So if you crack the code of learning physics from its core, from its fundamentals, then you will start enjoying the process of learning physics, you will get results. You will get amplifying your results without getting frustrated. And the same effect you will be able to experience in other subjects also. Because if you are strong enough in a difficult subject like physics, then other subjects will be very easy for you. Okay. So I invite you to register for my free webinar, which is called as Physics Made Easy, by clicking the link given in the description below. So signing off, we will see tomorrow is Sunday. The timing of the live tomorrow is 10:30 a.m. in the 10:30 a.m. IST. So we will be discussing some general topic related to our life and physics, connecting our life and physics. So signing off, great day wishes to all of you. Thank you for watching here. Thank you.